Okay, cool. Hey guys, how you doing? Um, let's see. So today we're gonna talk a little bit about I don't know what are we gonna talk about. Maybe we're gonna talk about a badge. um, we're gonna talk about the Defcon 29 badge. This is at the request of Admiral Potato and all the crew here at 801 Labs who was playing while we were playing, and they all got stuck on Jenny, which we all know about, right? We all love Jenny. So other than that, I mean, we'll talk about it. This is kind of Waylon's passion project. So let me introduce everyone. My name is Mike, or Bash Ninja. We've got below me, we've got Zevlag, and then to the right of me, we've got Professor Plum. So I mean, let's give you like 10 seconds to tell us about yourself because not everyone knows who you are, and they just kind of want to figure it out.
Go ahead,
Yeah, I'm
Zipline.
Zevlag, also known as Josh. I'm the game master for the Hackers Challenge at St. Con every year, and good friends with Plum and Bash Ninja, and we had a lot of fun hacking the badge this year at DEF CON.
Sweet.
And I'm Professor Plum. I'm a Utah local here. I get sucked in to capture the flags. I try to stay out, but this year I did not. I knew I was going to play this year, and we went all in this year. We started probably 2 weeks before the actual conference, right? Working on things, and yeah. Bash, how about you? Are you going to lead the show and kind of talk through
Yeah,
things, right?
I'll kind of lead it and talk through it, so you guys don't have to do too much work. I want to start off and say this was Plum's passion project. Kind of what happened was is I mean I know Plum not just in that through the community, but through we have professional contacts, right? And we went to lunch during one of those work meetings, and he was talking about how he's going to do it and how he was shooting to get the black badge this year. And I know I was like, you know what? I mean we've played with the badges before, right? We played them in previous years. We played with the DC 27 badge. I know you played the DC 26 badge pretty hard. And I was just like, let's just
And
do it again.
we've been really close too.
Yeah, like really close, except none of those years were black badge years, which was important to us. But but you said this year you were gonna go for gold. Actually you're gonna go for black, right? And I was like, I will hop along for the ride. I want to see how far this goes and see what we can do. And I mean, it was super fun. But yes, so we started, like you said, like 2.5 weeks before the conference because of the fact that the badges, I mean, it's not, I wouldn't call it a leak, but it was a leak, right? Because they had all the virtual badges get shipped out. Um, so, I mean, Josh, you want to tell us a little bit about that? You were a part of that too.
Yeah, so this year we had a distinct advantage with the DEF CON being a virtual event. That they had to ship virtual badges even with the preliminary firmware that was neutered and had minimal functionality. There was a lot for us to learn from that.
Right.
And big props to I'm just gonna call out Complicated Mike because I see he joined in. He's here in the channel listening, but awesome badge, and I don't know how you could have done anything more besides giving it a non-functioning firmware. So even then, there's a lot to learn from the hardware.
Mm-hmm. So actually, speaking of which, I want to show everyone. Do you mind if I show everyone our Google Docs? Is that okay?
Please do.
I don't know.
Okay, cool. Let's do it. I'm actually really excited to share this because this was kind of like, I mean, it was mostly you, Plum. Sorry, mostly you, Zevlak. You did all the work to make this show up in this doc here. But I mean, it was all of us sitting there collecting this information, making it happen. So this is kind of like a Google Doc that we created. Let me see. There we go. I can focus it for everyone that we created. Most of it was done before the conference even started. This is like weeks in advance, right? And so we
I
went
don't see
through.
your screen bash.
Oh, you don't see it?
There it is. My fault. I see it.
Okay, cool. So we started off just going through and collecting all the pieces of information we possibly could about this badge. I mean, you can see the slew of information we collected. We created a puzzle solving sheet because of course there was puzzle solving. I mean, do you want to go over this one, Josh, since you organized it and set it all up?
Right. You're doing great. We just as you approach a puzzle, and whether it be a Defcon badge or any of the puzzle, it's important to gather all the pieces, everything you can find about it, and you have to document it somehow. And I think our documentation was actually a key to our being able to solve this puzzle as quick as we did, because there were so many puzzle pieces that back referenced
Hmm.
both hardware and puzzle pieces.
So while he's talking about, it, I'm just going to continue scrolling through. We picked.
So yeah, we dissected information we could find from everywhere, from the forums, people that had their badges and when we didn't have them, and they posted their interactions in the terminals, to tearing apart the hardware, and Professor Plum mapping out all the pinouts for everything on the processor, guesses and things that we knew.
Mhm.
We document things that we need to do. We highlighted in the document stuff that we didn't know and said, hey, we got to ask these questions when we get a chance, or probe the badge in this way to find out what it really does.
Plum, do you want to talk about kind of how you figured out some of these pinouts?
Yeah, I won't get too interested. Well, I won't get.
Just like a 30
Yeah.
second highlight, not like showing us
Okay.
code or anything.
Yeah, well, I could if you want, but that would take us a detour. So there's a few plugins, and Zevlag actually pointed them out in that document somewhere. So I used Ghidra for this, and there's a nice Ghidra plugin that will take an SVD file, which is basically a XML type document that comes from Atmel or ST Micro, and it describes the memory layout of the device. And so I can load the firmware into Ghidra, and then I run this script, which takes that SVD file, and it takes all the memory addresses from the SVD file and maps them into Ghidra. So, for example, on a microprocessor, when you write to port A, what's really happening is you write to a memory address, 040001, and that's the port that's mapped to those pins. So when you look at Ghidra, you just see a bunch of writes to memory, and it's very confusing. But the script will match those memory addresses up to ports, to devices, to UART, to timers. And so that in Ghidra, then I'm seeing, oh, they wrote to port A. Oh, they configured the UART. Oh, they wrote this to the UART out. And that really helps kind of drive the reverse engineering. It's a
Exactly.
very helpful script.
So I mean, for those who weren't sure, Ghidra is the reverse engineering toolkit released by the NSA, and yes, and it was super helpful to have all of this stuff because we could see that we have USB devices, we have UARTs, and to the point where we figured out that there were what looked like touch sensors, and later in the badge, once we physically got it, we realized that this right here was your volume knob. um, different cool things like that. Specifically, one of the funnest parts is from the art board, we were able to, just by knowing the kind of challenges people do, we were able to identify spots that we assumed would be kind of your electrical engineering challenges, your jumpers and test points. We weren't sure if they were at the beginning if there were things that we would measure or if they were but we figured it out at the conference specifically. But like this right here, you've got your jumper here that is bridged initially, and the other one down here is open, and then you've got your spots here on the actual chip itself where we assumed what they're doing. So we knew that these things were things that we would need to look at. We didn't know what they would do at that point, but we before we even went to the conference, we knew that these would be part of the challenge, and it was pretty cool. Just scrolling through, you can see all the little pieces of art that we thought might be useful. Most of them weren't. Some of them were. Um, a lot of them were really. It was really fun to go through and identify all the different scenes. I'll make sure to share the different scenes, but it looked like um, based on the whole badge, that front board was based on the scene from Serenity. It didn't really help us with the challenge. It was really cool where you've got this 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 guy sitting staring at a bunch of screens, right? This guy and all the screens, then all the different items that are on the screens are what we found what was important. Anyways, so that's kind of the prep work we did. We ended up buying a bunch of hardware too, right?
We did. So because we could see what the board had and we knew the processor type, we had JTAG debugging. We bought a Tag Connect. You can see on that screenshot right there that we know that you can see it in the top right. That's the debug and programming interface. So I made sure I think Bash and I both bought a cable so that we could interface. Again, never used it. And then we also bought those connectors that you can see hanging off the side. I think I still have some. Oh, they're in my office. But we bought a few of them so that we could connect to those connectors should we need to.
Yeah, so actually, I have some of those right here. So like, here's one of the leftover connectors that we had. He just bought, them. This is the coolest part. You found these connectors just by looking at pictures and us like digging through DigiKey and Mouser trying to figure out what they might be.
Ash found them.
Well, kind of. And you even ended up ordering the wrong one and having to get it, another one shipped in.
Yeah, I did click the wrong link, but we did get the right ones. And
Yep.
this is very different, right? Usually when you go to Defcon, you have no idea or very slight idea what processor, what you're expecting. You just take your toolkit and hope for the best.
And just for the other people, this is your Tag Connect that goes on that port right there. This cable itself, super cheap, right?
Yeah.
For those who know, this cable
cheap, definitely cheap.
But this cable alone, it's $60 for a stupid cable. I don't know why they charge so much, but they did. Gotta love it, right? And then this is at least what I use. This is the programmer you would hook in, so you can actually go through and dump the firmware. Now, Mike gave us the big solid, and we didn't actually have to dump the firmware this year.
Yeah, the U2A interface was really nice for pulling firmware.
But usually you have to.
Yeah. That would have been a leg up for us because we would have been prepared to pull it had that not been there. But
yep. Anyway, so the date. So we got to about this far before we got to the conference. Everything after in this document, which we kind of stopped using, as things got hot. We did afterwards. So these URL endpoints. This was really interesting. So this was mostly you, Plum. Do you want to talk about how you got across with these endpoints before the conference started?
Yeah, I'm prepared to. Do you want me to talk? Yeah. Okay, we'll talk about it now. May I share my screen?
Sure. Go ahead.
Oh, it might take me a second because I guess I haven't done this before. Let's see. Oh, give me just a second.
And for everyone listening, go ahead and start dumping questions or thoughts that you've had in the voice text channel. And as we get downtime, we can talk about the things you're all interested in. Or after we get, when we get to the end, we'd love to, answer questions and talk about the things that you want to know. Oh, we lost Plum.
Yeah, I think he had to grant permission to Discord, which required it to restart.
Can you see me? Hello.
We can hear you, but your video is still off.
Oh.
But we can see your screen.
Okay. Okay.
There we go.
So, yes. So let's see where we left off. So Wednesday, before the conference technically starts Friday. They usually start giving out badges Thursday, and I'm at Black Hat, so on site Wednesday, and watching Twitter, and I noticed a speaker make a mention that he just got his badge, and I was like, oh, this is way early. And so I hounded him over Twitter, and I was like, where are you? I need to see you. Like 10 seconds is all I need, right? And I told him, like, I really want to we're trying to work on hacking the badge. I'd love to see your badge. And so he was nice. He's like, I'm actually headed over to Black Hat. I'll meet you. And it's like, okay, anywhere. So I meet him. I like sit down like right in the middle of the hall where we were, take his badge, pull the firmware off it. And I was like, okay, thanks, bud. and actually we chat for maybe 30 more seconds. But I wanted to get reversing that firmware because I figured that firmware probably had the final shell firmware. And luckily I was right. That firmware did have all the puzzles built in. So I had the firmware at like 4 o'clock on Wednesday, and like things aren't even going live until Thursday. Conference doesn't start until Friday. So that was a nice leg up. And I got the firmware, and one of the first things I did was, besides diffing it from the other one, is I just went through what strings are in there, just getting a good idea of what's new. And one of the first strings that stuck out to me is this: "Thank you for doing your part to keep the signal going. To continue your journey, go to." I was like, oh, well, here we go. We just see where we need to go and we're good, right? So in IDA, I'll double click that string, and then I can hit X to show me the X references. So that shows me what functions are using the string. I've named this main output. At the time, it just said sub, something, something, something. So we'll go to that function, and I'm going to turn it into a nice, pretty C-looking code. So real quick, this is the steps I went through, just a little faster. Bash, I promise not to take too long here.
No, this is the most interesting part for me.
That string is obviously going to some kind of standard out, right? So I'm just going to call this printf. It might not be printf, but it's print. It's print related. You can see this carry to return and new lines. So these are like probably print char, right? So thank you for go to defcon.org signal, and then there's some print new lines and this one sub function here that I don't know what it is, but I thought, okay, this has got to be it, right? Like defcon/signal something something something. So let me go check out this function real quick. So we'll jump in there, and this is actually the function that did the XOR decode. This one decode and then prints, and it takes in an address. Let's go back here. It takes in some kind of address and a number. And so if we look at the function, it does a for loop over that second number. So that second number must be a size. And then what it does is it fills this buffer, iterating over it with the input buffer, minus 128, and then XORed with something, whatever's right here. And we can go check out what's right there. Oh, I just not going to want to show me what's right there. Fine. We'll go like this to get there. Where is it? Decode print. And my number. Where's my number? There it is. Oh, for offset. So it XORs it with welcome to DEFCON 29. So all I need to do is write a quick function to take the input, XOR. I didn't actually, so subtracting 128 is actually the same thing as XORing with 128. We're just flipping that bit. And then we'll XOR it with this string here. And I'm going to show you a cool way to do this. I love Python, and I love that you can do Python right inside of IDA. So check this out. This is going to be ugly, but there's a function in IDA which lets you get a byte at an address in Python. Can you see? This is really tiny down here. And I don't know if I can make it bigger, down in the bottom left.
It's tiny. I can read it, but it is pretty small.
Oh, let's see if there's a way to make the font bigger. It's around here somewhere.
You can also use your Windows accessibility features by pressing Windows Plus to zoom in down there.
Oh, even in a V, I don't have a plus. Wait, look at that! Wow. Okay, so this is going to be difficult. IDA has this function where I can say get a byte. So, mouse, don't do that.
Windows minus to zoom back out.
Okay, let's try zooming out. Oh, does not want to do that. Killing me, Smalls. What's going on?
Go up, and you can just hit the accessibility thing.
There we go.
There you go.
Okay. Why can't I get out? There we go. So I'm going to go grab that address. And I'm going to zoom back in. So what I did is I put that address where the welcome to Windows is, and it gives me byte 87. And if I did a char on that, that should be the capital W of welcome to DEF CON, right? So now that I can get the byte, I'm going to write a quick. This is ugly because I'm ugly at writing code, but I get it done fast is what we're trying to do. So I'm going to use the Python building a string. Is that zoomed in enough? Do I need to zoom in some more?
No, that's pretty good.
All right. Okay, so I just joined, and then I'm going to do a lambda for doing a for loop here. For x in, let's say s is going to be my size variable. For x in s, we're going to start at that address where the welcome is, which was at 0702 plus x. So, we're going to iterate over that, and we're going to XOR that with 128, and we're going to XOR that with the source string, which we don't know what it is, but we'll use that as a variable. Get byte EA plus I. And then all of those, I want you to turn them into a char, not an int. So, talking through this real quick, we're going to XOR, we're going to walk over length S, and we're going to XOR those two together and with 128. And then this dot join is just going to make that into a string. Now this isn't, I don't think this will work. Yeah, it doesn't, it's not going to, what did I do wrong?
You started it with a double quote and then you ended it without.
Is that a double quote?
At the very beginning.
Should be two single quotes. It does look like two double quotes. I agree, but it should be a single quote. Okay. So X get byte EA for in range S. Yes, that should be fine, but it's not worth liking me.
Did you finish the parenthesis for char?
Maybe. Let me shrink that. It's just a hair too big for X. Oh, because I said I here. There we go. Nope, still doesn't like it. Oh, that's right. Range. Yes. Sorry about that. Somebody probably saw that and knew. Okay. So that just decoded one of these that I had my pointers at. I should have not had my pointers at, so it didn't give it away. So now that I have that one liner, I'm just going to make this a function where I give it the length, the string I want, or the mess I want it to decode, and the length, and then just paste that in there. Oh, wow, forget my mouse does that. Cut and paste that. Okay, so now I've made myself a decode function, and all I need to do is just say decode, and then the address and the length, which, if we go back up to the code, move out of my way, please. Go. Back up the code is right here, these 4 places, right? So taking those 4 places and putting them in there, I'm just going to put, so the first one is 0x f7 cb, and its length is 15. Oh, whoops. I forgot to say print, didn't I, in my function?
You can just, yeah.
Or return. So there's my function. And return. There. Now my function will work. So, oops. I just have to reload it again. If I run it, it says / what if I told you. Now I can go decode the next one. F7AB, and its length is 18. Your journey begins. F7BD, 14. Watch your head. And then the last one, F786, 19. It was totally aliens. So we did this in like 15 minutes. It took me probably an hour to do the same thing at the time. And I was a little bit more of a mess because I didn't know exactly what I was doing. But that's just in general what I did to RE. There was more RE available, right? We could see what other functions there are. But it was at this point that we knew pretty much the meat of what we needed to. We didn't even need to figure out how we kept the signal going or whatnot. We hit the meat before we even knew what the badge was. So we had these URLs, and I think that's when I passed them off to you guys, right?
Yeah.
I said, because we tried to hit them. Yeah, Bash, you want to take it from here? I'll
Well,
quit
yeah.
sharing my screen.
So we tried to hit these URLs and they were down. Thanks, Mike, for not releasing them early. um, and then we stuck them in URL watch. Which is a Python tool to watch URLs, see if things change, and hit it every minute. That actually gave us a whole ton of trouble, believe it or not. And if you want, we're not going to talk too much about that because it's a separate thing. But if you want a really fun puzzle, go try and hit the defcon.org page with Python requests and try and figure out why it doesn't work, because that was a nightmare. We eventually solved it, and we can talk about that another time. But we did watch for the changes. And so it was, what was it, 6:30 in the morning the next day on Thursday when we were awake and had noticed that these, URLs had gone live. And that's when the batch began. And so at this point, let me share my screen real quick. And then cool. And then that was kind of the end of this. So we kind of stopped using this document. We did a little bit more, but that was kind of the end of what we were doing here. So we realized that we could go to defcon.org/signal, right? This is the site that comes up. This is what showed up when we were live. You need to help the signal propagate. And then knowing the way that challenge authors write their stuff, the trick is you usually append this stuff to the end of it, right? So I think I'm trying to remember. It's been a couple of times now. Yeah. So we appended them at the end of it, and we tried them until one finally worked, and that was this one, right? And this is where the puzzles begin. Before this, it was a lot of RE, it was a lot of other things, but this is where we really get into the puzzle. So I'm actually, we weren't the only ones to eventually end up solving this thing, and because of that, there are people who've done write-ups and posted them online for people to see. So I'm going to pull up one of the write-ups made by Distro is his handle. He posted this on GitHub a while ago, and we're just going to work through. Go ahead.
Before we move on too much further, do we want to answer a question? There was a question brought up by Complicated Mike about what would be more difficult, how it would make more difficult to RE those strings.
Oh yeah, that's a great question.
Though, I mean, I think you noticed I saw one key string that told me exactly where to look, right? That was, if I didn't have that one string that kind of hinted at go here, then I would have had to start reversing more of the code to find out where the goods are. I can't say that I wouldn't have found something else to lead me there, but usually if there's a string like that, saved me a good bit of time. Another thing, what I was concerned that you might do, CompuKid, was that like if there was that station there and that we had to check in on that station and the station would then tell us the new hint that the data wasn't on the badge itself. That was a concern for me because then RE wouldn't buy me much, right? But yeah, it's hard because the attack, your device is going to be in enemy hands, and anything you key it with is going to be available to them. So that's one of the cases where if you want to roll your own crypto and do something kind of funky, it's going to buy you some time. It may not be the best thing. We usually tell you never roll your own crypto because it's going to get broken. But in this case, it's going to get broken. You're just hoping to buy yourself some time. It's like obfuscation.
Which is easier to do, to RE the weird crypto or to just actually solve the challenge?
Yeah, right. You're right. You're just trying to. It's like locking your house, right? You're just trying to make yourself a harder target than the next guy. Totally agree.
Cool. All right. Do we want to answer? The only other question we've got so far is from Admiral. saying, "Are there any secret goats?" No, Admiral. Sorry, there's no goats on the Defcon badge. Okay, it looks like that's it. So I'm going to pull up these steps. And the way that we did it is different than him because, again, we skipped some of these steps. So I'm just going to go through them real quick. The beginning of the badge, they start by wanting you to connect all the badges to the different types. Once you connect all the badges to the different types, they ask you to propagate the signal. So you have to share that signal 20 times to other attendees of the conference. And then, let's see, so then they've got step 3. Then that signal is what brings us to this page, I believe, right? So let's see. Do we remember? So one of the things I got to remember, we're going to have to resolve all of these. So this one, I believe this one was just a Caesar cipher, right?
Yeah. Or I think it was a substitution.
See.
Hey Bash, do you have my PNG? My mind map that walks through it pretty well in order too.
Yeah.
Oh, you're
It does.
right. Let me pull that mind map up real quick.
I just DM'd it to you in Discord.
Okay, perfect. Cool. This will save us a ton of time. Okay, great. So this is your mind map. So we've got the signal page, which we jumped all the way to this one. Your journey begins. And it looks like you called this one an alphabet shift. This is a ROT 13. Is that correct? Am I reading this right?
You're reading that right? Yep.
Okay, cool.
Out ROT 13, and then it decoded to the alphabet shift is what
Yes.
Complicated Mike called it, and was also the URL path. As you notice, it begins with a slash.
Yes. So one of the tools that I use a ton, is CyberChef, and if you're not using it, it's amazing. So I'm just going to pull ROT 13 in here, which brings us to the alphabet shift. Now, this stuff wasn't too hard. Most of you powered through this stuff pretty quick. But then we get to this page. Let's go back to that one. So this one was actually pretty frustrating. This one says the source of signal have shifted from place to place. Some are left standing, others are lost to time. We won't forget the ones that we've lost. Now this one actually got us stuck pretty good for a while. The solution for this one ended up, there's a lot of different routes you can go, but during our research in the badge, we kind of figured out that, the phrase signal, they talk about we being the signal, or the attendees of DEFCON. So when it's talking about the source of the summer signal, or us, has shifted from place to place, that really ties you to talking about where the conference is being held, right? And it's specifically talking about the conferences that were lost and not there. So the trick with this one is to go through and figure out how Mike decided to put order the hotels that DEFCON has been at, and that have either been, that were destroyed or no longer exist in some form. What we ended up doing was just brute forcing it, right? We just wrote a Python program to just hit every single page and just a bunch of orders until we figured it out. And we got stuck because the page, when you hit it, it sends you a 301 redirect instead of a 200, and we were looking for 200s.
Yeah, that was all my fault. And we got stuck for quite some time. We were here for hours because of I was walking right past the solution.
Yeah, so we were here for like, I don't know.
Well, and
go ahead.
And beyond the brute force, take note that you had to use a reputable source, not Wikipedia, for which hotels have been destroyed. Defcon.org was the reputable source for that.
Mm-hmm.
And so that's why we ended up even needing to brute force it, was garbage in, garbage out.
Yeah. So the answer ended up being in the order Sands, Sahara, and Aladdin. So let me just type that in there. In the same, and the other trick is in the same camel case format that we've done everything else. San Sahara. Shoot, I forgot.
Aladdin.
Aladdin. There we go. I bet I spelled that wrong. Yeah, I did. ALA. Cool. The Aladdin one. Okay, so that brought us to this page. This being the chip. This was actually a pretty fun one. I like this one a lot. Josh, you want to talk about this one?
Yeah, so this was a fun adventure. The chip shortages were a big challenge to everybody designing badges this year, but it's not the first time that this had happened. That badge supplies were difficult to get. And so by searching and researching about the various Defcon badges, we had fun learning the history of when electronic badges started around DC 14, I think, if I remember correctly now, and then all the way up now through DC 29, learning about the various microcontrollers that had been used, various controlled by parallax and Freescale chips, and learning about what badges used what and how they were done. Being DC 27s was cool as well with its was it 27? Yeah, last year. Yeah, 27s with the same chip that's used in ocular implants. But so back in DC 17 and DC 18 and DC 16, I think they all used Freescale chips.
I think we actually, yeah, we took notes of that, didn't we?
We did. And so obviously there were many years that used Freescale, and so we started trying to brute force it before we actually read the history and realized, okay, yes, DC 17, DC 18, they tried to get the chips in for DC 17, and then they got stuck in customs. And so they had to order a second shipment, a second batch of chips. And so come DC 18, they're like, okay, we're going to use the same chip because we got lots of them left over.
Yep.
And so we sat and brute forced that one for a long time, saying, okay, everything we do with Freescales and the MC part number and all sorts of various names for it.
Yeah, that one, the question was ambiguous enough. We didn't know if it was asking for the chip model or the years or the places. And so we were trying to brute force using a lot of different options. And when you're brute forcing these, any combination and any order, I mean, it adds up quickly. You can really only have 6 or 7 variables before it gets unwieldy.
Yep. The place that we actually,
and I'll note the brute forcing didn't work.
Yeah, it didn't work. So the place that we actually ended up finding it is we ended up actually looking at the schematic for the badge and seeing that it had the part number right there, the full, not just the chip name, but the full part number. And that's the solution. It was a pretty cool one. I like this one a lot, mostly because I got to learn a lot about the badge itself.
Later, it was fun to watch people pine over what's this 8-pin chip, and what maybe this graphic has something important in it, and can we find this exact image? And then it was blacked out and it wasn't redacted well, and so watching everybody else spin on it was entertaining.
Yeah, Bash had set up a Discord server just for us to start hacking on this. And what we decided to do is we built ourselves a private channel on a Discord server, but then allowed anybody who was generally wanting to work on the badge in the general channel. And that way we could kind of keep tabs on where the competition was while we were making progress.
Yeah.
And when observing them pine over some of these issues, that's where we just sat back and watched some of the issues, because we had gotten past this one by the time the general rabble had gotten there.
Mostly because a lot of them are still trying to find the 20 people and pair their badges together, because that took a lot of work. So then we get to Jenny. Jenny is everyone's favorite. No, it's not. So this is actually the one that got stuck, that got most people stuck for the majority of the time. And the first half of it got me pretty stuck, and the rest of it got. I mean, it was just this one was actually a really big stretch to go from what we had to the solution at the end. It takes a lot of little steps in between to get there. It's not just like one or two. It's all of them. Um, so this one you're given a picture. Here, let's. Did I lose it? No. Here it is. We have a picture of this lady with the name tag Jenny, and it's a GIF with two frames. Um, we test
That change colors.
that change colors, which is both interesting and super red herring-y. Um, so the first thing that we did is we worked on identifying who this person was. And some of the tricks that we did, let's see, we eventually figured out, how did we figure out who it was? I think we did an image search. That's what it was. So we did an image search and we found out that this girl's name was Jenny. Go ahead.
No, you go on.
From it's that
Forrest Gump.
Forrest Gump, right? And so Jenny from Forrest Gump, her last name is not Tones, right? And so that right there is something that stuck out pretty quick. Her last name is Jenny Gump or Curran, and not like the GIF is named Jenny Tones. So we've got this hint here that says Jenny Tones. We've got this hint here 1, 2, 4. And then we have a GIF that is changing two colors back and forth, right? So the, I don't remember who it was that made the next logical step.
We had two tones, which is the name of Jenny in the song.
Right. And so the way yes, exactly. So with that one, there is, I love your mind map here. So there's the hints with two tones, two frames, two different colors. So it's really calling out, all these things are trying to call it the two tone. And we eventually figured out that there was an artist named Tommy Two Tone who made the song Jenny with the phone number in it. So that would be, I would say, the first step is to go get to the song. The next step is going from the song and figuring out what to do with this other hint that we received, which was 1, 2, 4. Funny enough, 1, 2, 4 is not a number in the phone number in that song. So I think, Josh, you worked on this one a lot. Do you want to talk about how you make that next stretch?
Yeah. So this next stretch is a big logical leap, and and that's when our Word document came in, or our Google document, very handy. Is when we had started gathering data about the badges. We started collecting pictures of the badges and collecting all the information we could find about them. And so, which badges exist, what details were on them, how were they different. And so, go back to our solving sheet, the Excel sheet, the Google Sheets.
Okay, let me pull
batch.
that up.
It's in that Word doc, or you can find it there. Yeah, and back to that first tab. We had gathered that one. Yeah, that one's the badges. Yeah, we had started to gather all the badge types and the colors and which ones we didn't exist, like CFP and contest without outside vendors, all stuff that had existed in previous years as we were reading about Defcon badges. And so I started gathering this information and noticed that our white badge had a 3 mark on the inside of it. And so I started gathering details about other badges, what marks were inside them. And well, what do they mean? Is it just a tracking or ordering? And then somebody sitting next to us asked me a question, and said, well, what do we do with those numbers? And all of a sudden my mind just started blowing over, and I was like, oh, the same numbers, 1, 2, and 4 are missing here from my document as that webpage we're looking at with Jenny. And I'm like, oh, I know what we got to do. It was a big aha moment for me when I was like, okay, we got to just connect and put these badges in the same order as that phone number. And just like, oh, yeah, that's it.
Yeah. So you figure out that the Roman numerals match to the phone number, right? And so it's telling you that each of these badges represent one of the numbers in the phone numbers. the next logical step is to then figure out, well, how do we input that in? Do we do it by color? And then we eventually figure out that you do it by inputting the name of the badge, right? I
Yep.
gotta, and so that Jenny is one of the ones that stumped most people. Um, I mean, how long would you say people got stuck on Jenny?
Probably 19 hours.
Yeah, probably 19 hours. Um, And so I'm just going to copy and paste it here because I'm not going to type the whole thing up. But you go. It's basically 3 steps long, and that's kind of why it took people so long to get there. Um, and then with those steps, you eventually figure out that you need to put the types of badges in the order of the phone number that's based on the song that you're given hints to find on the webpage.
And really, the key there was that we started gathering this data as we saw badges, as we started connecting, as we were around. Like I had created this collection of information, just because I never knew what I needed for the whole puzzle. Our
Right.
whole document's full of stuff that, oh, what does this mean? Why is it this on the badge? We went every detail we had documented and said, hey, what is this cipher? What is this marking? What's this chip? What's this connector?
Right. So I would say Jenny took us like 20 minutes to get through. I'm not saying that to brag, but it's because of exactly what you said. It's because of having those phone numbers ahead of time. Sorry, those Roman numerals ahead of time. We were able to make those leaps that it was really hard to do. When you're at the conference trying to solve it, when instead of before when you're just slowly collecting information as time goes. So that was a cool, super good hit. So this one, the hackers have disabled our broadcast. This is kind of the next challenge. I believe with this one, we just did what we did with the other one. So we realized that we had extra endpoints, and one of them kind of seemed to look construction-y. So we try with every challenge, we would try each of the ones that we hadn't used yet and see if it bring us to the next one. Now we can talk a little bit about these and about how to do them the right way. But I mean, it's kind of fun to talk about the way we did it because I thought we did it the cooler way. um,
We can each of those that we came from the badge came from either jumping a jumper, removing a jumper, or connecting 2 wires. I definitely think we should at least talk about the aliens because that one's my favorite.
so yeah, we haven't got there yet, have we? So let's talk about the first 2 real quick because those ones aren't too bad. So the first one here, I have a completely new badge right here. The first one, so you when we skip past it, but you get at the very beginning you get a red pill that pops up, and you need to do something with this red pill. This here we decoded. And this is actually kind of funny to decode. It took get confused if yes, I'm using clippers. I don't care. Um, it took a few people a while to figure it out, but you decoded it as binary. I'm reading top to bottom, left, right. Instead of your normal way you read a book, you read it that way. And this says the word red. And so to get past that challenge, you cut this little jumper here so that the connection is no longer viable. The construction one you get by soldering this bridge together on the badge right here. So this is a solder bridge that is not connected, and you connect that and the reason you're supposed to logically get there is based on was it the max headroom, I think it was. It was one of the references on here. We didn't, like I said, we didn't spend too much time on that because I mean we skipped right past it. But one of the references tells you that that's the one that does does the jumper. Okay, cool. So there's that. Anyway, so back to here. So we're given a few hints here, and so let's just pull up the mind map that we solved. Um, yep, max headroom, and then come back here. So we're given. I love this mind map, Josh. This is really good. We're given this bit of text, and it ends up being a Visionaire cipher with the key being Defcon. So I actually do remember that I solving this one. This one actually wasn't too bad. So if you're ever curious and you're given text, there's lots of tricks. But I think one of the best ones is knowing that this is kind of in texty type format, there's a lot better talks that people have talked about doing crypto stuff. But there's this beautiful visionaire solver that he just dump these things into, and it kind of figures it out for you. And that's how I broke this one when we were doing it initially. So then you get your phrase, and you can go and read this guy's write up. He wrote a really cool method of cracking visionaire ciphers using keys that are normal words that you would use, not random words. Anyway, so we get here saying we've shared the signal from many spots. There's one that stands above the rest. It's a simple place without the slots. Some people think it's the best. And so for this one, we had to find somewhere, like obviously, one of the hotels or places that Defcon was held that doesn't have slot machines, which is really hard to find in Vegas. And this one being, if I remember right, this one was Alexis Park.
And it was Alexis Park, yes. And you went and found the damn slot machines. For me, I just remember that's one of the all-time favorites. Everybody loved Alexis Park.
Yeah. This one was not hard. Let's pull it up. I'm just gonna pull up the mind map. It's just, if I remember right, it's yeah, decimal to ASCII, but it's super annoying because you have to type the whole thing out.
We OCR'd it.
Exactly.
We didn't type it.
You OCR it. So that OCR, you just do decimal to ASCII, brings you to, I'm not going to do it because I don't want to type it again. Those keycaps didn't appear out of nowhere. They grew layer by layer out of some very particularly named vats. This one was obviously talking about the keycaps on the badge.
And we knew that CompuKid printed them himself, and I knew he had an array of printers, and I was like, I know he named these, right? But we didn't know their names. But the slides, yep. Go ahead. Sorry to interrupt.
No, you talk about it. I was just pulling up the go ahead.
Yeah, but we figured that the slides for his talk were on the media server. So we went and found his slides, and somewhere in the middle of the slides is a shot of the printers. And on them, there's a name for both the VAT and the printer itself. And zooming in, we could see the Seven Dwarfs and Snow White. But we could see Six Dwarfs and Snow White on the printers. Doc wasn't in the screen. He must have been on vacation that day. So we then were trying every combination of the Six Dwarfs and Snow White, or maybe the Seven Dwarfs. We figured Doc probably existed, even though he didn't make the screen. Trying to again brute force this by, we didn't know which order that he named that the URL would expect. Do I need to stall longer while you find the slides?
It took me so long. I was like, because he has the video on the other spot. But yeah, so we just found them in here. And this one actually took us a while too.
All right, there. That shot there, and the one above. Because you can't see printer number 2, but in the shot above, you can see printer number 2. So we zoomed in, and there's some tiny labels there. Yep, well, above. Those are the printer names, and above the printer on the blues, see each of those vats has a name, yep. And there's Six Dwarfs and Snow White.
Right, and watching the video, we actually found out that there was more than this. That they had Doc, they had, and one called Prince Charming. Yep, Prince Charming, yep. And yeah, I think that was it. We figured Doc because they said they had seven vats, one for each of them, and then they needed more, so they had Snow White. Then they needed more, they added Prince Charming, right? And then we tried to figure out how to add them and put it into the page.
Yep. So we were brute forcing all combinations of 8, 9 names, and while that was running,
well, none of those worked, and so we didn't even look for more dwarf names.
And it was still running because running through each combination of every possibility was quite a list. So while that was running and failing, somehow Zevlag and I got the idea that maybe it's just Snow White and the Seven Dwarfs, and he tried combinations of that. Right? You found that. You found that one, Zevlag.
Yep. It was just a question. We just like, well, what if it's not the names? What if it's the cat? Like, you asked the question, like, well, what if it's not the names? Like, oh, it could just be Snow White and the Seven Dwarfs, and not as literal as each of the individual names. And click, it went.
Yep. That one's kind of frustrating for me because we literally were. I mean, we were there brute forcing trying to figure it out, and it's kind of a pain.
Which I loved. Honestly, that makes for a great puzzle when it's not just the literal answer you'd expect, but it's still the right answer.
I liked it too. This one, life finds a way. So this is the next one. Life finds a way. Connections, not M&Ms. So connections. I'm just gonna tell you right now. Um, this is
Yeah,
the
Complicated
alien
Mike
one,
calls out.
right?
Complicated Mike calls out that the name of the page was named after, and so the back to the dwarfs, they were named after the dwarves, not actually named with each of the dwarves.
Oh, right. We missed that, and it took us a while to figure that one out.
Cost us, I guess.
Okay, so I believe this one was one that we pulled from here, right? I don't remember.
Yep. Yes, it was. But the story on this one, on the back of the badge, you tell the pictures before you go too far. You gotta tell the pictures. I love this one.
Okay. Here, oh yeah, let's just pull up the picture so we can actually see. Is that good?
Yep. So if you notice closely on the picture on the left, you see ET, and where they touch, that's a test pad right there. The center of their touch is a test pad. And then the picture on the right, which was very hard for us to determine what it was. Somebody on the forums found that one. That's the Independence Day shooting the White House scene. And at the center of the ship, where the beam is shooting from, is another test pad. And so that connections and about getting the signal over there was about helping ET make it the signal to the alien ship. And so you needed to the design was that you needed to make a patch wire from ET's signal to the alien ship, and then you get that URL line.
Which is really cool because ET phones home, and then you send his little phone home to his spaceship. I agree.
Yeah.
It was one of my favorite challenge too. Even though we skipped past it, it's still a cool one. Okay, so now we're on this page. He says, "I'm sure you tried to run strings on the batch real." So what do we use to obfuscate the strings? And then we get this here. If you notice, I'm always going and viewing the source, just because that's where all your hints go and different use, even things that aren't just hints, but they're required to solve the challenge. So this one is he's talking about. I'm sure you tried to run strings real. So what do we use to obfuscate the string? So this is talking about what Plum was talking about at the very beginning, that he did something on the firmware to obfuscate the strings. So the first step was solve that, and then you also need to solve this bits of these numbers here, which comes out to the text. At least it's not base 64, and then it's XOR, because XOR was the encryption method that Mike used, right?
Yep.
So
And so at least it's not base 64 is just the title comment. I think that those string of numbers were actually the same string of numbers that were encoded on the badge. I think that's actually one of the URLs. I didn't finish decoding that step.
okay.
I think that byte string is the same byte string as what's on the badge.
Yeah, and so okay, cool. So it's just /XOR. Let's just tack that in. So I mean, we knew that he had done XOR, so we blew through this one pretty quick too. Oh geez. So this is the last challenge, and this one was really hard. So you've got this picture of somebody using a heat gun. No, this is a blow dryer and making words appear. You've got a bunch of numbers with dashes, and then you've got the hint called declaration, and then look doors. So are you having fun yet? Year PLWL. So this one was from a movie. It's pretty useful to know. That's what this declaration is from. Um, what 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 was the cipher called for this one? Flag? I don't remember. Was this the door cipher?
Yeah, it's a door cipher. It's actually a French name, I believe, but it's a door cipher.
Door cipher. I don't remember what it's called. Is that really what it's called? Door cipher?
Where are
It's
you
called
looking at?
Ottendorf. It's the Ottendorf cipher. That's what it
That's
is.
right.
There you go.
Ottendorf. That's what it
It's
right
called a
was.
book cipher.
Yeah, so it's the Ottendorf, which you're right, is the book cipher. And so this was used in that film, National Treasure. So you pull it up, it's even here. It says it's discovered on the back of the Declaration of Independence. We were familiar with this one, so it was pretty easy to pick up what it was really fast. But you've got all these things, and with a book cipher, you have to know what book you're using. And this is being down here at the bottom, this is kind of telling you what you're doing. So it says year, which stands for this one, P, which we assumed was page, L, which was
Line.
line, W, which is word, and then L, which is letter. So we have to figure out based on this what books they are, and looking at them. I mean, the highest one is like 26, and it starts at 3, which is pretty
So
obvious. Go ahead.
it wasn't going to be 2003 or wasn't going to be 1903 or 1926 because it just didn't make sense. Whereas what happened to all the 40s and the 50s and the 70s and 80s? Come on.
Exactly. So it's the years of Defcon. I mean, the whole thing is about Defcon, so that's pretty helpful. And so with that one, what we did was we just went through and hopped on the Defcon media server and went to every single year, like Defcon 2, and pulled up the program and did what everybody else did and used the book cipher. So let's pull up the sheet that we used. This is our sheet. This is our lovely sheet that was just us going through. This took us an hour and a half to do.
Oh, a painful
It was
time.
it was painful, and looking back, it was probably way more painful to make. Because oh geez,
Yes.
I mean I
And this is
don't.
when we called in help.
The thing, this is what makes this difficult for me, is that we knew the page, but then every page layout was different, right? Sometimes there's 2 columns or 3 columns, and then there's a title and a subtitle, and like the time that the talk is. Do you count those when you're counting lines, right? Like, and then what about the page number? Some of them they're all PDFs. Some of them have page numbers on the page. So do you use the page number on the page, or do you use the PDF page number? Some of them weren't even really books, right? There was a lot of like, I don't even know if I'm doing this right when we're transferring these over. You're
This is
just
when
doing
Bash
this
Ninja had
work.
an awesome suggestion for us.
What's that?
This is when Bash Ninja had an awesome suggestion for us on this. This is why we started at the end of this cipher
Oh
and
yeah.
worked backwards.
So usually people tell you that they'll do a bunch of garbage and they're like, and your flag is this, right? So we started at the end and worked our way backwards to make sure that we were doing it right. And so we started down here and worked our way up. I actually kind of want to show them. So I got the Defcon 14 program. So here you've got, all your pages. But this one was really difficult because it's page 6. It's like, where in here do you start? Do you start counting here as a line? What about this? Do you count this as a line? It was really fun. Trying to figure out. And so what we ended up doing is, like, with that specific one, we had multiple letters that we decided that it could be. When we were that confused, we just did both and tried to figure it out till the point where we came up with a legible thing. And this was the last challenge, and the solution being email the decoded blank, because we couldn't quite figure out with that
Bottom.
one. It ended up being
It's
bottom,
bottom.
but we skipped it. We just got to the blank board cipher to you had the answer the whole time, right? And so we ended up, what's that, 3 emails trying to solve
Yeah,
this?
we sent 3 trying to solve it as we were making our way through it.
Solving this one, and we were just like, was this correct? And we get a bounce back, like, nope, we've got the wrong email. Next, is this correct? Bounce back, nope, wrong email. That was actually, I really like that. I wouldn't tell any challenge authors not to do that, because then you don't get people who think they've solved it and then they just stop, right? Having that quick feedback of you've made a mistake, keep trying, was super useful. But with the solution that says email the decoded bottom board cipher to this address, we have to figure out what that bottom board cipher was. And this one we had solved long before the conference, because we had all these pictures. At the bottom of the board, you've got this little bit. And this little bit decodes to we are the signal. And so the solution to ending the challenge was sending the phrase "we are the signal" to that email address. And that was it. That was game. Then we won. We called it. And then we rolled on the floor in happiness and went and got some food because we were starving.
So how did you know that you had won at that particular point in time? Did you receive a response email?
Yes.
Yes.
So Mike, CompuKid Mike, had immediate access to. I mean, that email went straight to him, and we just responded. He just responded back fairly quickly within probably 2 minutes, saying that we solved it and we'd solved it first. And that I think that's, let's see, what time, Zev, like, did we get that email back?
Looking for the timestamp now. Just a moment.
So I'm just really excited because this is my favorite part.
Just waiting for Gmail to load. It says loading. Okay, we are the signal. We sent the email at 8:55 p.m. and received a response back at 9:02 p.m.
Yeah, and so 8:55 p.m. on Thursday is when we solved the challenge, which I guess we found out at Defcon, like, the closing was 19 hours before the next team, which was super crazy. I did not expect to be that far ahead, but I think most people got stuck on Jenny. Um, you guys, is there anything else you want to talk about before we open up to questions? Nope. Okay, cool. So I went ahead and opened the permission so you guys can hop on the voice and you can ask us questions. We'd love to answer anything that you want to talk about. Cool. Well, I'm going to stop the recording then. It looks like we're doing pretty good. But I will hang out, and if people want to chat, we can.
Okay, I actually